So good morning, everyone, and welcome into week 6 of our Wednesday morning CPT 168 class. Good to see everybody. And got a lot to do today. As soon as I start class, a couple of people come in. Hold on just a second here. Let Mr. Daly in and let Mr. Edwards in. So we have a lot to do today. We've got a big unit to work on, and slowly but surely we're getting our act together. We're down to 2 people missing now. So let's go ahead and get started. I want to go over a couple of things with you guys before we get into the lesson. Let's see here. Yesterday, I sent you an email to remind you that unit test 2 starts next Monday, Tuesday, and Wednesday. It covers units 4, 5, and 6. So if you haven't uncovered that email out of your stack of email, please look for it. It has a few study tips in it. I'd like for you guys to do as well on unit test 2 as you did on unit test 1, maybe even better. That would be great. So we'll get that done next week. This week, we're going to study lists and tuples. If you haven't studied Python before, this is sounds funny, but it's really basically a chapter on arrays. If you have studied other languages, you might know them as arrays, collection structures. So if you haven't done so already, you need to read and study chapter 6. There's another discussion forum. You guys are doing good on your discussion forums. Those of you that are posting, it's either like you're doing really good or not doing good at all. But I got some grading to do. I'll get caught up with the grading this week. I normally do that on Thursday, Friday, Saturday, and Sunday. So we'll see if we can get everything done. Also, you have 2 labs this week, which we will talk about a little bit as we go through the unit, and a quiz. So the big thing for you to look forward to, in addition to doing unit 6, is to prepare for the unit test, which includes unit 6. It'll be units 4, 5, and 6. So these tests count a lot of points, and it deserves your attention. Does anybody have any questions about what's coming up?
Sorry, did you say the review sheet, you were going to post that later?
It's already posted. If you'll read that email.
Yeah, I read the email. I don't see the review sheet in there where the email says it's going to be.
Oh yeah, it's in there. It's like one of the first bullets. So yeah, the review sheet is posted, and so have at it and go to it. Start studying. All right, ladies and gentlemen.
I'm sorry. I'm in there right now. It's not posted. It says it should be under tests, and it's not there.
Okay. Well, I'll make a note and go in there. It must have a date wrong on it. So T2 review sheet. When I get out of class, I'll turn it on. Okay. So okay, maybe we'll get started.
I'm just letting you know.
Okay. Thank you. Third try, we'll get going here on our unit. We need to get started because it's going to take every bit of our hour and a half together here. So let's get going on lists and tuples, unit number 6. We need to understand what a list is and how items in the list can be accessed. So just think of a list as a variable that has more than one piece of data in it. It's just basically a variable with a bunch of data in it. And to handle or manage these lists, we need to have some new methods to deal with. So none of these are terribly complicated. I think they're pretty much common sense, except for one of them that I'm going to try to explain for you today. But these 5 methods are append, insert, remove, index, and pop. and pop's a one that is a little bit different. So I'll talk about that in a few minutes. We're going to add to our programming vocabulary with two words that you may not have used too much in the past: mutable and immutable. Basically, the difference between mutable and immutable is data that can be changed or data that cannot be changed. If a data object is mutable, it can be changed. If a data object is immutable, it cannot be changed. So we need to understand that, because that's going to help us understand the return statement and how functions work a little bit better. Once we get all that done, that's almost enough for a chapter right there. We got some other things to deal with. We're going to take our vast knowledge of lists and expand it one more level to a list of lists. And a list of lists is basically a, somebody's got their mic on. Let me see who that is. Let's see here. Guess I cut it off. So a list of lists is a two-dimensional array, or two-dimension of lists. And it is really used a lot in programming. So that's why the writers of this book put it right away in this unit. Then we'll have some functions that we can use to work on lists. And these, once again, are fairly common sense. These are things that you can work into processing items in the list that may help you with your programs: count, reverse, sort, minimum, maximum, min, max, choice, shuffle, and deep copy. We're going to get to all of those functions and learn those. We need to understand the difference between a shallow copy and a deep copy, and that's kind of tricky. And then we're going to learn the difference between a list and a tuple. A tuple is basically a list that is immutable. Lists are mutable and tuples are immutable. And then there's one more point. We've actually studied multiple assignment statements before, but we're going to see how to use multiple assignment statements with tuples. So it's a big unit, and that's why I wanted to go ahead and get started on this thing as fast as possible so we could get things done today. And so let's see what we can do with it. So far, you guys have been working on variables, which basically store a single piece of data, whether it's a number or a string or something like that. And now we just want to grow that. We want to grow that, and we will do that by understanding what lists are. Lists are a collection of data items. Therefore, they're called a data structure for collections. We have two types, like I said: lists and tuples. Lists can be changed. Tuples cannot be changed. So lists are mutable and tuples are immutable. So think of a list just like you would a grocery list. Going to the store, you have a list. Think of that list in your hand as a variable, and you got 10 things on there that you want to pick up at the grocery store. That's all it is. So we don't need to overthink it. I think that's one of the biggest problems when we start studying arrays and collection variables. We overthink it. We make it harder than it has to be. One thing that we need to remember about lists is that they are sequence structures. So they just are, the data is stored in the order that you add it to the list. There's no natural sorting or anything like that. We have to actually run a sort function or another function called sorted on a list if we want to change the order in which the lists are displayed. And we'll get to that in this unit too. So I don't know if some of you guys in the class are programming majors and you may have studied C# or Visual Basic or any other language. All languages have arrays or something that behaves like an array, and that's what we're doing here. Now, each of the items in the list are referred to as list items or indexes in Python, okay? Whereas in other languages, I've told you in the past that I am pretty good at, or pretty familiar, I better not say pretty good, but pretty familiar with PHP. In PHP, we call these arrays, and each of the items is an element in an array. So if I slip up and call these elements, that's what I'm talking about, but I'll try not to do that. It just makes it confusing. So the first thing that we need to do, hold on just a second here. Something is amiss with somebody's microphone, so I am going to do that. All right. So we need to learn how to create an array, create a list. This is not hard. We create it just like we do a variable that has a single piece of data in it, but we put a comma between each of the pieces of data that we want to put in the list, and then we enclose it in brackets, square brackets. Square brackets and comma separated. Couldn't be easier. And we can put all of one type of data in a list, or we can mix types of data. Early on, we'll see examples where all the data types are the same, and then we'll get into another example about halfway through here, where we'll have integers, strings, and floats all in the same list. So we don't have to worry too much about data type when it comes to this this data structure. This, yep, don't want to do that. Let's see here. Okay. Hold on just a second. Things are just not working smoothly this morning. Okay. So here's an example of how to set up a list. Just assign it just like you would a variable, the name of the list, the assignment operator. Then in a set of brackets, you just put the list items separated by commas. So examples here's some temps. Here's a list of temps, a list of strings, a list.
I'm not sharing anymore.
Great. Okay. Things are definitely not doing what I want them to do. Hold on just a second. Let's just see what we got going on here. Man, oh man. Okay, I should be sharing now, right? You got it? Are you guys there?
Yes, yes, we see it.
Thank you very much. Okay. I'm not making a good grade on Zooming today. All right, so let's go back here. So this is how you set up a list. Set up the name of the list, followed by the assignment operator, each of the items, separate them in commas, with commas, and enclose the list in square brackets. And you can see here we have all types of lists that we can do. We can have floats, we can have strings. Here's a string, an integer, and a float in one list. And we will use some empty lists from time to time. You can create a list with nothing in it and then use coding to populate the list. So that is something else that we can think about. Another trick, just to kind of put this into our toolkit, you can use the repetition operator when you create a list. I don't have a good example about why you would want to do this, but say, for example, you wanted to initiate a list that had 5 scores in it. And so a quick way to do that is to create a list that has a single 0 in it. And then you could use the repetition operator times however many items in the list you want to repeat. So the end result would be this. We're not going to really use that in this particular unit, but that's one way to do that. All right, so there are, having done this class yesterday, I know two very annoying things that we're going to have to understand as we work our way through lists. And once again, cannot explain why, but the indexes in the list start numbering at 0. And we need to remember that from the very beginning, because as we look at the coding for lists, we will refer sometimes to the index numbers rather than the contents of the list. And when we do that, we're going to have to compensate in our coding for the fact that the indexes start at 0 and then go 1, 2, 3, 4, 5. And so that is something we will learn to live with. So we can refer to or reference any of the indexes if we know the index number, and there's a method for us to determine numbers of the indexes. And also another neat little trick is you can work from right to left. Typically we think left to right going across the list, but we could work from right backwards to left if we use negative numbers. So many times we'll want to refer to the last item in the list, which will be the most recent thing that's added. So you can think in your logic that you might want to pull up the last thing that you added to a list. And so that reference would be -1, index -1. We'll see how that works here in a few minutes. Also, you can count, once again, from right to left. So -2 would be the next to last one, and -3 would be the next to the last one, and so forth and so on. So here's 2 different ways to refer to those index numbers in a list. We have a list of temperatures. I think there are 5 temperatures in this list. And so 2 ways to point to the same thing. We could look at index 0, which is 48, or we could count from right to left, 1, 2, 3, 4, 5. That would also be 48. And so we just have a column here working through this. So we looked at 1 and -4, they would be 30.5, or 2 and -3 would be 20.2. So you get how this example works. So we can count from left to right or right to left. Just realize going from right to left, we are going to use negative numbers. And if we go from left to right, we have to compensate for 0 here. We have to remember 0 is there. And once you get that under your belt, you'll understand exactly how to refer to the items in the list by the index number. So we need to understand how to get and set items. We've created a list, and so we set items. That's how we add items to the list. And we get items by pulling items out of the list. It is not, once again, terribly difficult. We're just going to use the assignment operator. And the way I think about this, and maybe this will help, it depends on which side of the assignment operator where the reference is to the index will kind of determine whether you're getting or setting. So if you have the list and an index number on the left side of the assignment operator, then you are getting, and you're actually setting. And then on the right side, you will be getting. So we'll see how that works here in just a sec. So it works very similar to the way we deal with variables in the past. And there's only one little trick here to worry about. If you refer to an index that does not exist, you'll get an index error. And that's fairly logical. That I would think would be common sense once again. But just if you're trying to write some code and get or set list items and you get an index error, that's going to be your issue most of the time. So for our example here, you can see that we have a bunch of temps once again. So notice that we have a variable name on the left and we have the indexes on the right. Okay. So this is going to be getting. That's what I was trying to refer to a second ago. So we are basically pulling a value out of the list and assigning it to a variable so we can work on it in our code. Very common thing. So we refer to a index that does not exist. Index 5 does not exist in this little list. So you can see we got an index error out of range. And it works pretty much the same for strings as it does for floats or integers. So that should not be a problem. Down here, we are setting. So because lists are mutable, they can be changed. We could enter something like the name of the list with the index number, and we want to change it to a different value. Very common practice, okay? So that works. Just kind of in the back of your mind, try to follow along with the data types. It's real easy to get tripped up on data types when you're working with lists. So be sure and enclose your strings in double quotes. If it has a decimal point in it, it's a float. You know all the basics that we have already studied. So let's look at 5 methods for adding and removing items to our lists. One very handy method is the append method, which, as you would expect, will add an item to the end of the list. It just increases the list by one item, one index, and puts it at the end of the list. Insert is exactly what you would expect. It has 2 arguments. You have to give this method the index number where you want to insert a particular item into the list. Now, once again, remember, we're going to start counting from 0. This would work. Typically, this would work from left to right. I guess you could use a negative index if you wanted to and try it from right to left. Remove is pretty straight up. You just enter a item reference, an item index, or the item contents, and they'll be removed from the list. Index is the one I was talking about a second ago. It's a method that if you don't know what the index number is of an item in a list, but you know what the list item is, then you can run the index method on it and it will return the index number, which may be helpful. Now, the hardest one of these to understand is pop, because pop is a twofer. It does 2 things. It does the same thing as remove. It's going to remove a item from your list, but it's also going to allow you to assign it to a variable. It returns the value. So in most cases, you're going to use a pop more than you're going to use remove. Remove just takes it out. There's no collection of the value. There's no way for us to refer to the value once we remove an index. But if we pop it, and people use it as a verb all the time. So if you pop a index item, then you have that returned to a variable if you want to. So you can do that. You can return it. So just remember that a remove method will remove or delete the index from the list, whereas a pop also removes or deletes it from the index, but it also returns or gets the value of the index item. I don't know that that's terribly clear other than that one little statement there in the table we just looked at. So I wanted to stress that, make sure you understand how pop works. So because these are methods, these are not functions, we are treating lists as an object. This is object-oriented programming, whether we want to do that or not. So we have to use the syntax for the object. And so once again, we have a couple of lists up here, a list of stats and an inventory list, 2 totally unrelated things. And so on the stats list, we want to append. So look at the syntax, the name of the list, a period, and the method we want to use. And we want to append this value. And so append is really good. We're going to use that a lot because it will just add a new index to the end of the list and put that value in it. Insert, well, here's the name of the list. Inventory is the name of the list. Dot insert, the name of the method. We want to go at index number 3, and we want to insert robe. So 0, 1, 2, 3. So it's going to take the place of bread. Okay. You see that robe is inserted here. And because we are inserting, then the indexes above 3 are going to move up 1. They're going to move to a higher index number. So bread started out at 3, now it's 4, and potion's gone up 1, 2 as well, has increased. And then remove, inventory, remove shoes. This is the easiest. It just looks from left to right until it finds a match for whatever this string is and removes it from the index. That will be the reverse of insert when you're looking at index numbers, because then all of the index items to the right of shoes are going to go up 1 as they shift to the left. And then there's pop. So pop is fun. So here's our our inventory list, similar to what we were just looking at, and we're going to pop an item. So notice the syntax has changed here. Item equals inventory.pop. When you do not reference anything in the parentheses, pop will go straight to the last item in the list. So this is going to pop bread. Bread is the last item. And so now item is going to equal bread, as well as bread's going to be removed from the list. We could do it by item number too, or we could do it by the contents of that index as well. So pop is pretty important because you get the ability to also collect or get and assign that value for whatever item you're removing to a variable, so you can use it in your code. You'll see that in an example. Now, there's another way to do this that will keep you from getting an error message, and that is to use an if statement to look at the contents of the list, and then if the index that you want to, in this case, pop, if it's there, then pop it, okay? So first off, I equals inventory.index hat. Now what we're doing here is we're looking at the inventory list, and we're using the index method to find the index number for hat. So I equals 1. Okay, so all we were trying to do is get this index number. And then we can run inventory.pop I, and that way we're not going to have any error message. I think I said if statement. That's a different example. I got ahead of myself there just a skosh. But this is a way to do this using the index method, which is a good way to look up those index numbers. There's a function that is handy when you're working with lists. It's the len function that will tell you how many index items there are in the list. And so you can understand pretty quickly the depth of the list that you are going to process, okay? I think I'm going to stop right here for just a second. Been jumping around way more than I should this morning, and I haven't even had a whole cup of coffee. So I'm going to stop right here and see if anybody has a question before I add more to our knowledge base here. Anybody have a question?
I have a question about using the index method.
Yep.
So it says that it returns the index of the first occurrence of a specified item.
Correct.
What if I wanted, like, say there's 2 instances of hat in a list, and I wanted to know the index number for the second instance of hat? Would that be possible to do? Or is that something we would be learning later on?
Well, I'm gonna kick the can down the road, as they say. Anything is possible. Okay. Uh, Let me think about that. That's a new question. Let me think about that a second. If you just were looking for the index numbers, um, I don't know. I would have to play around with that. I'm not going to give you an answer for that right now. We're going to have to look that one up and come back to that one. But that's a good question. Anytime you ask a question is a good question. But that one stumped me. Man, oh man, I must have got up off the wrong side of the bed this morning. I'm just trying to think if I've ever looked for more than one occurrence of the same. I know how to do it. Count. Okay. Count will do it. Nope. See, I'm jumping ahead. Count will tell you how many times it's in there, but it won't tell you what the index numbers are. Okay. We'll see that coming up. Maybe that'll help a little bit, but it's not going to totally answer your question. So let's get back to Lynn here. Totally blew that too. Here's our inventory once again. And this is the if statement that I got ahead of myself on. So another way to do this, using the in keyword. I love the in keyword. It can do a lot of work for us. So inventory is our list. Here's our list of what? 4 things. And item is going to equal bread. So one way we could do this is if item is in the inventory, then run it through the remove method and remove item. Once again, this is going to work from left to right. One of the things I like about using an if statement for removing or even popping for that matter is you can keep yourself from getting an error message in your code. This is a safe way to do it. Now look at the if statement. This shows you the power of if when it's applied to a list. If you remember back when we first started looking at if statements, we didn't have this structure. This is something new. And you're going to see it is used in example after example after example from here on out. But it is a way for us to dig into a list and uncover something with very little code. I don't know, that just impresses me. So kind of pack that away. I think you're going to use this structure in your code down the road. So one way, now, this is not very glamorous, but one way to answer your question, Chris, would be just to print the list to the screen and count. That's not what you were asking, but it would give you the answer. So it's very easy to see all of the items inside of a list. Just use the print function, and in the argument for the print, just enter the name of the list. Super, super easy. Now, a for loop is really handy to use with a list. You can use a for loop to actually populate a list. And that is something you will also do in future units in our course, because you will read a file off of your hard drive, off of your storage system, whatever it is, SSD or hard drive, and you're going to read it into memory. You're going to open that file and you'll want to look at each line of that file, and you'll create a list of each of the rows in that file. We're going to actually start working on some of that next week. So that's very powerful programming. We're really, really getting in high gear when we get to that point. So pay special attention to the for statement as it goes through a list, opens up a list, and gives you the ability to look at each row of a file or each item in the list. So loops are a good thing. Once again, it's that in keyword is so powerful. So for whatever we are trying to this would be the variable that we're looking for in the list. So for each item in the list, then the end keyword list. That's so simple. Be sure and put a colon on the end. We always put a colon on the end of ifs, whiles, and fors, any of those type of control statements or other control statements we put colons on, but those we definitely got to remember. And then we have statements here that are going to be process statements for the data that's inside the list. So if you remember, I'm going to go back 2 slides here. We just used a print function to dump the list to the screen. That's not very glamorous. Compare that to running it through a for loop. So here's a little short list. And then for each item in the inventory, colon, print item. So now each item has 1 row. That's important because we basically printed 3 times. Instead of 1 time, we printed 3 times by going through the loop. And that's very helpful, very helpful. Now you can do the same thing with a while loop. We'll go ahead and get that out of the way. The problem is when you do the looping through a list with a while loop, you're going to have to deal with the index, the counter, the length. You got 3 things that you're going to have to work with, whereas the for loop will do all that for you. You don't have to do it. So by far, the for loop is easier to work with. But for full transparency, full disclosure here, we'll see how to do the same thing with a for loop and then with a while loop. So we have the same list for both these examples, 4 scores. We initialize the total, okay, and we use for to loop through the scores list. We want to look at each score. And so for score in scores, colon, then we just want to add each of the scores to the total on each loop through. This is syntax that you've seen now for a couple of weeks, and then we'll print the total. So we're just basically incrementing by the score the total each time we go through the loop. Now, PHP class, if you've done any of that, this is a for each loop, okay? But we don't call it a for each loop. It's just a for loop in Python. Here's a while loop that does the same thing, okay? It has, 4 scores in our scores list. Same thing here, we're initializing the total. So we also have to initialize our incrementer. We've got the incrementer count, okay? So while is less than the length, there's the length function we talked about. So this tells us that we have 4 indexes. Then total is going to increment the scores, but we have to reference each of the index numbers when we use a while loop. And if I was trying to write this from the top of my head without looking this up, I would forget that because I would be thinking about this. We don't have to reference the index number, but we would in a while loop. And then just like we do in any other while loop, we're going to have to increment our counter. So we have to increment I up 1 for each loop. And then we do the total, the print total the exact same way we did in the for loop. So I think it's pretty easy to see that we're going to use for loops for that purpose. Okay, excuse me. In chapter 4, we learned about numbers and strings and Boolean arguments in a function. And we basically said in those functions, if we calculate a number, a string, or a Boolean, we have a Boolean argument, we're going to have a return statement. This is the second kind of tricky thing in this particular chapter. So just realize that we're gradually creeping into object-oriented programming here. Python uses objects to store data of all data types, including strings, integers, floats, Boolean values, lists. Each one of those is an object. The difference is when you change the value of a, say, an integer, you actually create a new object when you create that new value for that integer. That because integers are immutable, lists are mutable. That's the difference. Okay. So we want to kind of get our head, we're not changing anything that we were doing from a coding standpoint. What we're doing here is trying to understand why we were coding the way that we did. So just realize that strings, integers, floats, and Boolean data types are immutable. They cannot change. So when we want to assign a value to an integer data type that we have already been using in our code, we basically create a new one. So in contrast to that, we have a list object that is mutable. It can change. It's a subtle difference, very subtle in our coding. Where we're going to see it is when we write functions. Okay, when we write functions. So they come into play when you pass arguments to functions. For example, think about this. In that case where the variable name in the calling code and the argument name in the function both refer to the same object, we're going to have a situation where we're going to need a return. Okay, you'll see what we're talking about. You've actually done it. So whether or not you have to return the result of the function depends on whether the argument is immutable or mutable. And most of everything that we've done up to this point has been immutable. So when we wrote our own functions, we had a return statement in them because we were returning a string, an integer, a float, or a Boolean value of some type. Compare that as we move forward now to lists, which are mutable. We don't have to have a return when we have a function that creates a list. So, for example, down here at the bottom, we'll see just basically what we've been doing. We're defining a function here, double the number, and then we have a value for whatever we want to double, okay? And so value equals value times 2. That's how you double a number. Well, a new integer object is created. This value is not the same as that value. I know this sounds like it's a big deal. The book's making a big deal. Don't overthink it once again. Just realize because we're working with an immutable type, we have to have a return statement here. So we have to return value. So here's an example of how we would call that, the calling code. And so value 1 equals 25, an integer object is created. And value 2 equals double the number, value 1, that's going to create another integer value, integer object. So we can print those objects, no big deal. So all we're doing is just changing our terminology here a little bit and understanding that we have to have a return statement on any function where we are returning a string, an integer, a float, or a Boolean value. So here's some more examples of doing this with a list, okay, because lists are mutable. So add to the list. This is pretty simple. Notice there's no return here. So list.append, using the append method, whatever item it is we want to add. So now instead of writing this code, we could call it using a function, kind of a simple example, overly simple. So here's our inventory list. We call our function, okay? So our function has, as we wrote up here, we have to have the list name and the item we want to add. So add to list, inventory is the list name, robe we want to add, then we can print the inventory list. We see robes at the end. There was no return statement there. Just a small thing, okay? So that we get this right on test questions and things like that, I wanted to give you one whack at the kind of the review descriptions at the end of this. I don't remember what page number this was in the book, but it's in chapter 6. And I want you to focus on the fourth and fifth points here. When you pass an object to a function, the argument name in the function refers to the same object as the variable name in the calling code. When you pass an immutable object to a function, the function can use the argument name to create a new object, but then it must return that object to make it available to the calling code. Okay, so just kind of stack that away for a rainy day. I don't know that it's going to change anything that you've already learned. You already understand the return statement, and I guess the reason Murak put this in the chapter, and since it's in the chapter, I want to make sure we talk about it, is because you won't be using return statements with lists because they are mutable, not immutable. Interesting little program we're going to work on in our examples in Unit 6. We're raising our programming skills every unit, and our programs are starting to get a little bit more complicated. So we'll see kind of version 1 and version 2 of movie list in this unit. So we have a menu. This is just a bunch of print functions here displaying the instructions for the user. And then we have a prompt that asks for a command. So we enter list. It's going to list all the movies that are in this, actually a little database. Okay. If you really want to know what we're working towards here, is we're working towards using lists in a database or from a database to maneuver a database, to manage a database. Okay. So very important. Look at these numbers here. 1, 2, 3. There are 3 movies in the list. Okay. Here's the problem. Where'd 0 go? Okay. So that means in the code, to get this to print properly to the screen, we have to compensate or offset by 1 to make sure we compensate for the list indexes starting at 0. So that is a big deal. That's important. Okay. We'll see that in the code in a minute. Add. Okay. So we add something we're going to append. We already know what method that's going to be. And if we del 1, look at this. We del a number 4 here. We're going to delete Casablanca. We just added it. So we're going to delete it here. Notice we have a return here of Casablanca was deleted. So that should tell you that one of 2 things happened. We either ran the pop method in the code, which is what we will do, or we had to run 2 pieces of code. We had to figure out what index Casablanca was and populate a variable with that value and then remove it. See, that gets complicated. Or we pop it, and pop it does all that for us. That's why we like pop. Okay. So let's look at the code that does all this. First, the hierarchy chart of our functions, and following suit with what we have learned earlier. We have a main function. We have a display menu function, list movies function, add movie function, and delete movie function. So we've got a total of 5 functions in our code. The display menu function is real simple, just a bunch of print statements. To list the movie list, okay, we are creating that function, and we're going to use a for loop to do this. And so I equals 1. We're creating a variable named I, and we're initiating it at 1, not 0, but 1. Okay. And then we go through a for loop. We basically are going to look at the list and see how many movies are in there and print them to the screen. So for movie in movie list, and this does not have to be named movie, by the way. In his examples in this book and the PHP book, he uses this syntax in this for loop, where he has the name of the list or the array, and then each item in that list or array, he has a very similar name for that variable. And It doesn't have to be movie. It could be anything you want it to be. And I've had students complain about that or tell me that's confusing to them, because you're going to see an example in this unit where it would be like movie and movies. There would just be an S on the end of the list. And that is a little bit harder. So just realize that these are names that we create as developers. You can have your own style. This is Murex style. So for each movie in the movie list, print the string, the string I, because we're inside a print function here, we want to make sure we convert that integer here. We didn't have that in quotation marks, so that is an integer. Now we got to run it through the string method to convert it to a string. We want to concatenate here, so we want to put a period right after the one and a space, and then we want to concatenate one more time and include the name of the movie from this variable, and then we print it. Or actually, this is a blank line. We printed it there, and we have a blank line here. Just increment the value of I there, 1. So that's the list. Adding, we're going to use the append to put the new movie on the end. This is super easy. So the only thing that's different is we're putting a end of line in the end of the print statement here, the print function, to make sure that we have some spacing there. That's just a format. So there's nothing much I can add to that one. And deleting. Okay, now we are going to have to compensate for the 0 in the delete function, the way this is written, because we're dealing with the number of the movie that we want to delete. So we want to convert the number input into an integer here. And then we run it through an if statement for data validation. Love the data validation. So numbers got to be between 1 and, notice the nice use of the length function here on the list. So this is a good example of why we would want that, because this list is going up and down all the time as we add and delete movies to it. So this will give us the length of the list, and it'll print if we're out of range there. And then else, movie, once again, is going to equal, and because pop is going to return that value for us, we run the movie list through the pop method number -1. And that -1 right there is to compensate for the indexes starting at 0. Then we print this is why the pop was used, so that we would have a value for movie. In the case we saw was Casablanca, and then we concatenate here was deleted, new line. The main function, we create our list. And what we're going to do next week, instead of doing it this way, we're going to read a file off of the hard drive. And that is so cool, but it's complicated. It's going to require several lines of code, but that's where we're headed as programmers. We want to be able to store our data and save it between sessions. So right now, this is not storing anything. So here's kind of a list of movies, just a bunch of titles. And then we run the display menu. Then we get into our while loop, while true, capital T, colon at the end. This is the strength of the while loop, makes it real simple to code. So while this is true, go through this if statement, this if else statement, to be honest. Okay, it has many parts to it. And the code is very simple. This is how we're going to handle menus for the majority of this course. So this type of structure is going to be used over and over and over. And once again, if we put something in that's wrong, we get a nice polite error message. When we're done, we get a bye. Okay. And then the if statement that makes this the main module. Okay. So are there any questions about the code in this movie example, movie list example? Anybody see anything that's got you puzzled? Nobody's asking any questions, so I guess we're okay. You just gave me permission to make everything twice as hard now. Because we've been dealing up to this point in the unit with a single dimension list. Now let's make it a two-dimensional list. And that means that we'll have one list that has a bunch of lists inside of it. Yeah, that's crazy, isn't it? The list, then inside that, a bunch of lists. Now that one variable is going to have a ton of data in it. Not just one list, but a bunch of lists. That makes it two dimensions. Coding this is easy. Understanding it from a logic standpoint is a little bit more complicated. Okay. So to create a list of lists, and that's exactly what you call it. That's nothing I dreamed up. That's what it's called, a list of lists. Students is a list of lists. Inside students, we have three lists. We have the Joel list, the Ann list, and the Mike list. Okay. It's pretty easy to see what's going on here. We got Joel and 3 scores, and Ann and 3 scores, and we got Mike and 4 scores. Notice we have 2 or an extra, let's say it this way, an extra set of brackets. And that's what makes this a list of lists. We have 2 brackets at the beginning and 2 brackets at the end. And so the lists in between become a list of lists. Back to our movie theme, here's a 3x3 list of lists. So movies is notice it has an S on it. Movies is the name of the outside list. I think of this as nesting. It helps me understand it. Maybe that'll help you. But that is the list of lists. And then inside we have 3 lists. Each one is a movie. It has the year the movie was released and I guess how much it costs if you buy it. I don't know what this last number is, but it looks like a cost. Could be a ticket price going in. There's no heading here. So we'll have to assume that that's how much it costs, maybe a DVD or something. Or in today's world, a download. Okay. So how do we add to a list of lists when we code it? When we code this so that we have a program that deals with list of lists. Okay, so rather than reading this off our storage system, we'll create a list of lists here, movies, okay? So we have the outside. This is the list of lists. Look at this part. Notice and be kind of watch the S on the end. That's going to help you understand what's going on here. To easily populate the inside lists, each of these lists for these movies, we're starting off with an empty list. Told you that we would have an example of an empty list. So movie equals empty, okay? So we will append to the end of movie the name of the movie, then the year, then I guess this is the price of the movie. There it is. And then look at this, we're going to use append again, but with an S on the end, that is going to add this movie to the end of the movies list of lists. Let you ponder that code for a second, because that is something to get your head around. Look at that for a second and see if you have any questions. A minute ago, we were using a for loop to pull the movie out. Now we're putting the movie in. Okay, so now that we have a list of lists, we have to refer to each of the items in the list of lists with 2 indexes. The first index is going to be the list of lists, and then the second index is going to be the index of the list inside the list of lists. Okay, so in movie 0, which is the first movie, then list item 0 would be the name. So the first movie that is in our list of lists is Holy Grail. The second index, which is the third piece of data because it starts at 0. So the price of the first movie was $9.99. Once again, we're going to get index errors if we get out of range, okay? So we want to know the name of the second movie in the list. It would be index 1, which would be the second list in our list of lists, and the first index of that list inside the list of lists is Life of Brian. Ponder that for a second. Is anybody grabbing for their mic button? Okay, everybody's good. Okay. So we can print a list of lists the same way we printed a list, just dumps it all to the screen. There's no formatting here, not very fancy. We can use a for loop to make this a little bit nicer, okay? So this little for loop is real small, but it's doing a lot of work, okay? So we want to loop through each line of the list of lists, each of the inside lists. So for movie in movies, colon. So we want to look at each movie inside the list of movies. For each item in a movie, okay, print that item and then put a space and a vertical line and a space. We're changing the end of each of those movies, okay? Each of the items in the movies. And then print a blank line when we get to the end, just a blank line. So what that's going to do is you can see each one of these movies, each of these two-dimensional lists that we were working on is listed in a way that is much easier to read, okay? Because we used basically an embedded for loop here to go through each of the movies one at a time and print each of the items with a separator on it, okay? And one on the end here. Any questions about that code? Because we're going to see it over and over, that kind of thing. All right, so I think we kind of hammered this enough. Python is a list of lists. In Python, a list of lists is where we have a two-dimensional list. And we have to think of this as data in columns and rows. We're basically building a little spreadsheet, okay? Having that information at hand, we can now elevate our skill set on this movie list we're working on and add, change it from a list to a list of lists. We have 2 pieces of data, 2 columns in each row, okay? So the code is almost identical. There are just some changes. So I'm going to try to point out the changes. They didn't highlight them for me, so I'm going to have to pull them out as we go through here. So in this this example in the book is basically the functions that change. Okay, it's not the whole program, but the functions that change. So the first function that's going to change is the list. Okay, when we regurgitate everything that's in our list. So we want to list the movie list, whatever it is. So if the length of the movie list equals 0, then print there are no movies in the movie list of the end of line and return, okay? So this is immutable, okay? So we have to have a return there, okay? So else I equals 1, okay? For row in movie list, each row, notice we changed that from movie to row. Told you it can be named anything, just be consistent, okay, in your program. So print, and once again, changing I, which is the number here, to a string, period. All this is the same. This is the same, basically. Each row, which is the variable in the loop, okay? Each row, index 0 is going to be the name of the movie, plus we have a space and a parentheses, and then we want to concatenate a space, and then we want the string of the value in the second row and second column, which is was it the year or the price? I think it was the year of the movie, right? And then we want to add to that a closing parentheses. So this is different, this code. We're dealing with column 1 and column 2. Okay. And then let's see down here, we're adding a movie. So adding a movie, because we're adding 2 inputs instead of 1, we're going to create an empty list for each new movie we're adding to the list of lists. And then we are using the append method to do that. Okay, I think you can follow along with that code pretty easy. And then we have to remember to add the new movie to the overall list of lists. So movie list, we want to append that movie to it. And oh, by the way, we want to print movie 0, which is the movie we just created here. The title of the movie was added in a new line. Deleting a movie is very much the same, I think. Let me look here. Yep, I think that is the same code as what we saw before. And display menu, they moved the display menu down. Okay, I got this. There's the display menu. And then we are just adding some data to our movie list so we can make it run in the display menu. Our while loop is going to be the same. Okay. I don't think there's any change there, and there's no change in the if statement to make this the main module or main function. Okay. Now we've really done a lot in a short period of time here. Are there any questions about the 2D version of the movie list program? I think this is a really big change right here. Big change there, big change here. Okay, not much change the rest of the way. Okay, so just think of it as a 2-column spreadsheet that you're dealing with if you have to visualize it. And either you're all asleep, dazed, or whatever, but I'm trying to get to the end on time. I ran way over yesterday. That's why I'm trying to speed up today, and I'm messing up. But anyway. 3 more methods and a function here that are going to help us do creative things with our lists. Count is a way for us to see how many occurrences of a particular piece of data are in our list. Reverse, just remember this is a sequence collection, so it reverses the sequence. I don't know, I mean, there are certainly ways that can be important, but don't have a good example right off the top of my head. What I'd have a big example is sort. Now, sort and then the function sorted, they're 2 different things here because remember, we're dealing with objects, okay? So sort will sort the list. It's not going to create a new list, but it's going to sort the list that you're working on. And if you do not put any key equals function in the argument, it just does it in a normal alphabetical descending sort, just like a normal sort. Numbers before uppercase, uppercase before lowercase. Remember that whole thing we did a week or 2 ago? So that's just a normal sort. The key equals function argument is going to be, as we saw before, where we will want to use the lower function to lower the case of the input so that we don't have that uppercase, lowercase tap dance that we were doing in earlier units, so that we treat all the characters in the data as lowercase. We could do uppercase, but I think we're pretty much going to do lowercase in this class. Now, the difference between sort right here, which is a method, that's dealing with the object, okay? Sorted is actually going to create a whole new object, okay? So this will change the list, the current list. This will just create a new list for you. So you have to name it. You have to give it a new name. And this is the list that you are sorting. And this is the key function. Again, the same thing if you want to change case would be a good example. So this will be the list that you are creating the new list from. And this will be changing case. You would use an assignment operator and a variable name to come up with a name for the new list. Okay. So first, the real quick examples of count, reverse, and sort methods. Count, we have a list of numbers here. We want to count the number of times 14 shows up in numList. So numList.count 14, and this is a value, not an index. Okay. There are two indexes that have 14 as the value. Okay. Reverse the order in which these were entered, and change the sequence. Okay. Notice there's no argument here. It just flips the order. But sort is cool. Okay. This may be something that you will use. It's going to affect numList, which is the list we're running the sort on. And it puts it in this case in numerical order, numbers, uppercase, lowercase in that order. Unless we add key equals function, which we will see here. So count reverse, we covered that. We covered this. Okay, this whole thing about the case, this is almost verbatim repeating what we saw in an earlier unit. So we use the key argument to specify the lower string, change the string to lower. Okay, so this is a function that will do that for us. Sorted creates a new list. Once again, we want to sort based on case, basically. So here is what happens when we sort a list. If we do not change case, pear is going to come before apple. Okay. So here's how you use the string dot lower function, okay, that we talked about before. Food list dot sort key equals string dot lower, changes the value of pear to lowercase p during the sort, but it doesn't change the value in the list. Okay, so that's kind of cool. Puts pear in the right place. We got the same thing with sorted down here. So we're creating a new variable here, sorted underscore food list. And we're running the sorted food list. This is a function, not a method. So we print sorted underscore food list. Once again, pears in the wrong place. So we use the key equals string dot lower to get pear where it's supposed to be in the sort. And that's because of the upper and lower case problem. Don't think you guys will have too much of a problem with that. Min and max, you have a string, a list, and you want to know the minimum value that's in the list or the maximum value in the list. Pretty easy to do that. Choice and shuffle will be good if you're doing a little game type program. So you have a list and you want to randomly select an item. You can do that. You have to import the random module for these two guys. By the way, these two functions are in the random module. And shuffle just changes the sequence of everything that's in the list, makes it random. Okay. So I don't think you'll have a problem with that one either. So here's an example. We have a list of numbers, num list, and min num list in parentheses will give us our minimum of 2. Max is going to give us our maximum of 84, pretty straight up. We want to import the random module here so we can use the choice and the shuffle functions. So num list, and there you go, there's our list. So from the random module, run choice on num list, and it's going to return a random item from num list. Shuffle is just going to shuffle it up. Okay, so now once you run that, you're going to have a different order, which is good for gaming, for creating a game. So those methods and functions are pretty common sense items. Now, this is not common sense. The difference between, well, let me just kind of approach it from the right direction here. We're not going to worry about a difference yet. When we copy one list to another variable, you would think that you are creating a totally new list because we have copied variables in the past and they are separate variables, okay? That is not the case with a list. What you do when you copy a list is you're actually creating something called a shallow copy. You're creating a second object, but the two objects are linked together. That is very weird. That's something that I would not assume. I don't think you would assume this. So just realize there is linkage between the original list and the second list when you do a shallow copy. And so if you change the value of one of the indexes in either one of the two copies, the effect is going to be on both copies. That's the problem with shallow copies. So list 1, 1, 2, 3, 4, 5. So list 2 is going to be the same as list 1. We're going to just make a shallow copy here. And we're going to change the value in list 2 for index 1 to 4. When we did that, notice we changed the value for index 1 in both of the two lists, list 1 and list 2. That one's a gotcha. Okay, that is a problem. There is a solution, and that is deep copy. Deep copy is a function. It's not just a simple assignment operator, okay? So what you and I think of as a copy, here's one copy, I'm going to put it in the copy machine and come up with a second copy. That is a deep copy, and it creates two unlinked separate objects, okay? And that one is going to screw you up until you get that kind of sunk in your head. That's one of those things that can mess up your day. Just remember, deep copy is the only way to get two totally separate, unlinked objects, okay? So deep copy, and then the argument for the deep copy function is the name of the list that you want the deep copy of. And then you have two lists that you can deal with separately. So remember that we have to import the copy module to get deep copy. That's another part of this problem. Okay, so import the copy module. We got a list here, list 1, 1, 2, 3, 4, 5. And so list 2 is going to be copy.deep copy list 1. And now we can make changes. We made the change in list 2, just like we did a second ago, and it only affected list 2. So that is a serious difference and a serious thing that you need to think of, because there will be many times that you will want to make a copy of a list, and you have to use the deep copy function to do that. And to do that, you've got to import the copy module. Okay, processing, basically how to deal with items in lists. From time to time, you will only need a certain number of the items or the indexes in a list. Not just one, but a little range inside the list. And so there is a way to slice out just certain indexes. That is called slicing. Just think of it as a knife, slicing the data out of the list. And there's 3 arguments on the slice. Well, actually, and I did this yesterday, it's not a function or a method. It's just a way to reference. You can do this in any command or whatever that you're doing to process the data. It is not a function. It's not a method. And I don't know why I can't remember that. Maybe by Thursday night I will. But so just realize when you are slicing, the key to slicing are the colons between the brackets. That's really what makes this work. So up to this point, we've been referring to indexes singularly inside the square brackets, okay? So I think it was in range where we had the stopping value was actually, you got to remember it's offset by 1. We got the same kind of situation here. So a list of numbers is in our list, just a bunch of numbers. And so we want to refer from the beginning, 0, the first index, and we want to stop at 2. So that's going to pull 0, index 0, and index 1. Okay, just like range, remember that's going to be 1 up. We have to offset. So 0:2 is going to refer to 52 and 54 in this particular list. You do not have to, at the beginning and end, you don't have to refer to those indexes. You can just do it by leaving it null. So :2 will do the same thing as 0:2 in this example. And it works on the end the same way. So if you wanted just to slice off the last 2 indexes here, and since there are 1, 2, 3, 4, 5, 6 indexes, and you wanted 5 and 6, index 5 and index 6, then 4: would do that. Okay. 4:, or you could do 4:6, I guess, if you wanted to go that route. Now, if you want to step, okay, and we've seen stepping in other syntax. So this one's going to require a second colon. So if there are 2 colons in your reference to an index, automatically Python's going to assume that the number after the second colon is going to be the stepping value, okay, whatever you want to step. So in this example, we want to start at the beginning, we want to end at 4, okay, and we want to step by 2, okay. So that would begin at the beginning, 52, and we will skip the first one and go to the next one because that is still within the range that we created, and that's 56. And this is 4, 5, and 6. So remember, we got offset by 1 on the end there. Now, you can also reverse the order of the indexes using the step in value too. Use a -1 and that will reverse the order. You could also use the reverse method that we saw, but you could also do something very similar by putting a -1 in the stepping value when you refer to a index. I'm getting a headache. I know you guys must be too. There's a lot to this. Okay, so let's look at how we can concatenate 2 indexes, 2 lists together. And there's 2 different ways we can approach this. Is it kind of a permanent thing or is it a one-off? Okay, so if it's kind of a one-off thing, we want to create a 1 variable that's going to include both indexes. We just use the plus operator, super simple. The first list and then the second list, just join them together with the plus. However, if you want to basically append one list to another list, you would have to use the plus equals operator, okay? So now inventory is going to be increased by adding chest to the end of it. See what's going on there? So when we print inventory, now inventory is changed. I said permanently. None of this is permanent because we haven't stored it anywhere, but you see the difference between the plus equals and the plus here. We're creating a new object here. We're just changing because this is mutable. We're just changing the inventory object by appending chest to the end of it. Okay. So we did all that and we haven't said one time what a tuple is. Okay, so a tuple is just like a list, except it is immutable. And because it is immutable, it cannot be changed. We don't use tuples all that much. Okay, we're going to use lists a whole bunch, but we're not going to use tuples that much. Okay, so that's the difference. Now, from a creation standpoint, to create a tuple, instead of using the parentheses that we use, excuse me, the square brackets before, we want to change those to parentheses. No square brackets. We're going to use parentheses. Still use commas to separate the values or each of the indexes in the tuple. So parentheses instead of square brackets. Now, once again, we have comma separated. If for some reason you're starting a tuple or you're creating a tuple, you can't change it. So you're creating a tuple that only has one value in it, be sure and put a comma after that value. That's in the book, so I thought it was noteworthy. I have no idea why that's important, but it's there. It's got to have a comma after it. And we access items in the tuple same way we do lists. So we can do gets, but we can't do sets. There's no way to do a set. You're going to get an error message. But you can do gets the same way. Okay. Okay. So how to create a tuple, syntax exactly the same. We just change these parens to square brackets. Okay. So here's a tuple that has a bunch of float values in it, 5 float values. Here's a tuple that has 6 strings. Here's a tuple that has different types of data in it, string, integer, float. So all that should make a lot of sense. Code that accesses items in a tuple, pretty much the same deal, okay? None of that is different than what we just saw. Now, we have a problem here. Have you figured out what the problem is? We're trying to set. Remember, if the index is on the left of the equal sign, we are setting. We're trying to set or change the value of index 1. And it doesn't really matter that this is a string. It matters that that is a tuple. And there's nothing in this code that tells us this is a tuple. The error message tells us it's a tuple. Thank goodness. That will tell you what's going on. You have to look at your error messages. Now, we want to be aware of the multiple assignment operator. We can do that just like we saw earlier with variables. We can do it with tuples if we want to. We could do it with lists. I don't know why we couldn't do it with lists, but so A, B, C equals tuple values, okay? So A colon, B colon, C colon, these are just variables, okay? The tuple has 3 indexes in it. So you can see now A equals 1, B equals 2, C equals 3. So the lesson learned here is that we can basically create variables that have all the values that are in the tuple and do something else with them. We can manipulate the data and then save it as a list or create a new tuple or whatever we want to with it once we unpack what's inside the tuple, okay? And there's some talk down here. Basically, it's just the same thing. We're using, creating a function here, get location. We have a bunch of code here that computes the values for X, Y, and Z. Because this is immutable, we have to enter the return statement because these are going to be numbers or floats. Okay, so we have to have a return, and then we can use the multiple assignment operator once again, or multiple assignment operation. And here's all the values that were calculated that created X, Y, and Z. And so we're unpacking it here to create X, Y, and Z as 3 separate variables so we can use that in our code. Don't know when you're going to have to do that, but I can tell you where you can see it, and that is inside the number crunching program. As we wrap up, almost on time here, that's why I was off my game here trying to speed this up. I want you to look at pages 190 and 192 when you study and go through each line of code in the number crunching program and make sure you understand each line of code. If you don't understand each line of code in the number crunching program, I want you to send me an email and we'll figure it out together. Okay. But that is your part of your reading assignment this week. Here are terms. Test 2 coming up next week. These terms are in play. Make sure you know how all of these terms work, what they mean. Go through the summary of each of the chapters, especially Unit 6 here, brand new chapter, brand new unit, and see if there's anything that this will help you with. This will help you kind of review and help you see the terms in the chapter in a sentence or paragraph that will maybe help you remember it. So I think summaries, especially in this book, are really good. So you got a lot on your plate this week. You have to read and study chapter 6. Hopefully you've already done that. I updated these slides yesterday afternoon after the Tuesday class. I made a couple of changes. So the latest version is available for download. I don't think I'm gonna make any more changes on it. So download these slides, use them as a study tool. Be sure and post your topic by Sunday in the forum for this week. You got 2 labs. You're going to work on the test scores program, and you're going to work on list of lists in the movie list 2D program. Got a quiz. Do the quiz over and over. Some of those questions may filter into the tests. So the quizzes are important in this course. And review the quizzes. Look at the quizzes in Blackboard again as you prepare for test number 2. Are there any questions? I apologize to you guys for being a bit disjointed today. I'm really not sure why, other than I was working on something right before class and got my brain in the wrong gear, evidently. But we struggled through it. Not my best performance as a teacher, but I hope I hit on the high notes for you. So anybody got any questions? Don't see anything happening.
I have a question. The recordings, where can you find your recordings at?
You go to bosanders.org, and actually there's a couple of ways. In the emails I send you, there's actually a direct link to the CPT 168 page at bosanders.org. And or you can just go to bosanders.org, go to classes, click on CPT 168, and then you'll be at the same place. And you'll see in the menu that the videos are listed there on the right. Just click on that, log in, and you'll see them. Thank you for that question. Every single class we've done is recorded and sitting there, as well as the other sections, by the way. So if you want to listen to yesterday's fiasco or Thursday night's program, they're there too. Any other questions? All right. Well, you guys have a good week, and I'll be watching my inbox if you have any questions. And please be safe. Take care of yourself. And we'll see you next Wednesday morning, bright and early. And I'll drink 2 cups of coffee instead of 1. Okay. So you guys have a good week. See you later.